Hey, and welcome back to the ALL NVMe NAS build. Today we're going to be shoving 24 terabytes of storage into this DAN A4H2O case. It's hard to get a sense for just how small this case is. So for comparison, here's what it looks like next to a standard mid-tower case. This is going to be fun. In our last video, we selected the AR900I for our NAS build. The AR900I covers a motherboard and CPU combo, but we'll need a Synology NIC with 2 NVMe slots in order to fit the 6 4TB Crucial P3 Plus drives, and we'll be using 96 GB of Crucial DDR5 for our ZFS caching. We'll also be using a 500-watt HDPlex power supply and shoving all of this into a DAN A4H2O compact case. But how does it perform in real-world conditions? Well, here's a test copying 7 GB at about a gigabyte per second. This is very close to our 10 gigabit per second theoretical limit. Next, we're going to install the fan. For the fan, I've chosen a slim Noctua fan. You can use a regular 25mm. That's actually what the screws that come with the motherboard will expect you to use. So if you plan to use something smaller like I am, you'll need to pick out your own screws. These are M2.5 screws. And the ones that we're going to use are the M2.5 by 16. We're going to go ahead and grab our case. So the case we're using is the Dan A4H2O. And we're going to start by installing the power supply. So the power supply we're using is an HD Plex. So this is the 500 watt HD Plex. Pick what power supply makes most sense for you. This case can handle an SFXL power supply here. I've been really liking the Corsair 1000 watt power supplies. Natural place for us to intake is going to be through the top here. If we were to run these fans as exhaust, what's going to happen is that we're going to have negative pressure. What I'm going to do is I'm going to run filters on the top here. And by running these fans as intakes, it's going to make it super easy for me to clean the dust for this. Now, before we install that, I want to go ahead and install the motherboard, right? Because we're going to need access to the top here to be able to route all these cables. So let's go ahead and just pull all these cables through the top. On the side here, and we're going to take off our regular power supply now. You might be wondering why I don't mount the HD Plex here. It's too long. Would have been nice, but it doesn't fit. It's taller than the case. Alright, now that we've got our 8-pin and our 24-pin power plugged in, we're okay to install our fans. So we'll go ahead and take these fans, grab the cables and route them appropriately. These are going to route to the 2 fan ports on the motherboard. Go ahead and screw these in. Next, we'll go ahead and reinstall our power supply shroud. Go ahead and switch screwdrivers here. For whatever reason, these ones can be a little bit tight to put in, and that other screwdriver just wasn't cutting it. Alrighty. So we'll put the filters right on top. This is going to block a little bit of airflow, but it's worth it. You know what else blocks airflow? Dust and hair. So this is going to make our lives a lot easier in the future. And they just magnetically attach there. Next up, we'll put our top plate on, and it just snaps in place like that. I think it's ready for our first power on. And it's on.
Alright, now that we know the system post, it's time for the fun part, the software. So let's talk about the drives first. For our 6 drives, I've chosen a RAIDZ2 configuration for our ZFS pool. That means that we can lose up to 2 drives, which is really important because in the event we lose a drive, we'll still have a backup during the resilvering process when we're bringing our drive back to full operational status. If we were to only run a single parity drive, when we lost that one drive, we would have no room for error. For this NAS, we're actually going to be configuring 2 different ZFS pools, one for our operating system and one for our data. You'll sometimes read online that ZFS can't work on partitions. It needs whole drives, but that's frankly just not true. In addition to the 2 ZFS partitions we're going to have on each drive, we'll need a third partition which will hold our ZFS Boot Menu bootloader. This project is what allows us to boot off of our ZFS pool. ZFS Boot Menu is a super cool project. It allows your system to first boot up to ZFS Boot Menu, which then mounts any ZFS pools and looks for Linux operating systems that it can start. You can then select any Linux operating systems you want to start from the dropdown. ZFS Boot Menu has install guides on their website for various Linux flavors. Please make sure to leave a comment below with either your favorite or least favorite Linux distribution so that the algorithm will favor this video. But in our case, I'm going to be using Alpine Linux. This video will differ slightly from the guide on their website because I ran into a few issues with their installation instructions. For example, my NVMe drives did not work using their configuration. I needed to add NVMe as a feature. You'll find the full list of commands to set up this NAS on my GitHub, which I'm publishing at the same time as this video. The Miniswarm motherboard unfortunately does a pretty bad job of detecting the speed our RAM should run. So we need to set this manually, but we'll also have to set the latency speed or our system won't post. So make sure to set all the values below. These values, unfortunately, will depend on the RAM you use. If you're using the Crucial sticks, feel free to copy the values I have here. The Miniswarm motherboard is really challenging to work with because it does memory training for about 5 minutes. And during that entire time, there's no way of knowing that it's actually working correctly. There's no indicator lights, there's no segment display output. You just have to trust that eventually it's going to boot. If for some reason your system won't post after changing these settings, what you'll need to do is power off your system fully, hit the CMOS reset button on the back of the motherboard, and possibly even disconnect the battery on the back. Go ahead and prep an Alpine Linux bootable USB using your favorite tool. We will need internet access for this, so plug in a network cable, and we're going to initialize our network. Once that's done, we'll need to add the repositories. This is how we'll install all the packages. Keep in mind we're installing these packages into our live environment, so not actually into our Alpine Linux install. This is going to allow us to set up our ZFS Pools. You can see our 6 NVMe drives here, and we're going to go ahead and wipe each of those NVMe drives. Make sure there's not any important data on them. These are fresh out of the box, so. We're going to go ahead and install Parted, which is going to allow us to do the creation of the partitions. We're going to install the bootloader first, so we'll go ahead and create that partition. Our drives will have 3 partitions on them total. This partition is going to be very small. It's just for the bootloader. Next, we're going to install the operating system. This will be a little bit larger. I'm going to allocate 50 gigabytes per drive. Should give us a total of 200 gigabytes for the operating system. Finally, we're going to prepare the network storage. So for this, we're going to fill the rest of the drive. And we'll need to indicate that the first partition on each of our drives is the bootable partition. And now we can go ahead and start creating the ZFS pools. I'm going to go ahead and enable compression on each of these. And we're using our second partition because this is for the operating system. Next, we'll create our data, which will use the third partition. And now we need to create our mount points. This will tell the operating system how to mount our ZFS pools. We're going to start installing Alpine Linux. As a reminder, everything we've been doing up to this point has been in the live environment. And we're copying over some of the files from our live environment into the new Alpine Linux install.
We're going to choose into that environment. Set our sudo password. This will be the root password we use when we log in next time. I'm going to go ahead and reinitialize our internet again. Here we're just kind of running through the install guide, installing the dependencies we need. Here's where we need to enable any features that we need for the operating system. So we're adding ZFS here, but also we need to add NVMe. This is not in the guide from Open ZFS Boot Menu, and tripped me up at first. If you don't put NVMe here in the features list, your NVMEs will not detect. And we're going to finally start installing the bootloader. We'll want to set it as the default boot. You'll notice I'm only picking one of the drives. So is the limitation of EFI, right? So you can duplicate this across all your drives if you want, but obviously only one of them will actually do the actual process of doing the boot loading. I don't have curl installed. Let me install that. And we're going to go ahead and set up our EFI boot. Just download this from ZFS Boot Menu. And we're also going to save a backup just in case. And we'll want to configure this. And now we're ready to reboot. So coming back up for our first boot. This is now booting off of the NVMe. There we go. We don't have any of our dependencies, so we need to install some of those again. But you can see our ZFS pools are up. We're going to go ahead and start configuring this Alpine Linux environment. Install cron. There are a couple things that we'll need to do on a regular basis on the NVMe drives. So to maintain the ZFS pool, we'll need to run trim and scrub. Those are not configured by default in Alpine Linux from what I can tell. So we're just going to add them manually as a cron job. And I'm going to schedule these to run once a week.
I'm going to add a group called NAS users. And I'm going to add myself. And also any other users I want to have access to this NAS. And I will need to make sure that the ZFS pool is available at a local directory so that Samba and NFS can access it. So I'm going to go ahead and mount it at /mount/data. And I'm going to go ahead and make a folder called projects, and I will chown that folder to the NAS users group I created previously. And I'll add both of those users that I created. And I'm going to expose this folder in two ways, one with NFS. So to expose it with NFS, I just add it here in my exports file. And the second way I'm going to expose it is through Samba, which I found works for both Linux and Windows, and actually tends to be a little bit faster than NFS. So we'll go ahead and just configure those directories here. There's Samba config. So at the bottom, we'll just add a new section here for the projects folder, specify the path, specify who can access it. We actually want it to be not public. And then we'll go ahead and make sure that Samba is running. And we'll run ifconfig, which will give us our IP address. So in this case, it's 192.168.2.133. Here I am on my Windows laptop. It has a 2.5 gigabit USB NIC, and I'm going to go ahead and set up the network storage. So I'll type in the IP address here that previously found, and then I just need to say /projects. And here we go. And I'm copying at the full rated speed of my network adapter. Right. So the bottleneck here is my network adapter. You could have 4 clients for simply copying at this rate. Okay, and we're going to jump over to Linux to where I have a 10 gigabit NIC, and you can see we're actually copying at the full rate of that network adapter as well. But if your workload is just reading sequentially, you won't notice a huge difference with an ALL NVMe NAS. This won't be the last NAS we build on this channel, I promise. But this channel is actually a software channel. For the sort of development workloads I'll be running on this channel, this NAS is going to be insanely valuable. Now you might be wondering, from our last video, we have an extra motherboard, right? I have some ideas for it. So I hope I'll see you around again for that video.